The first announcement that I already posted on the Blackboard. Next Wednesday, this time, all lectures canceled because of the faculty seminar day. Uh, if you do not know, be aware of it. If you know it, enjoy your day. Next Wednesday only, daytime. Night time, the class will be resumed. I think class will resume 4 o'clock, but that affects our class. So no class next week. Anybody wants to come, you can come, but there is no classroom, no class. Um, Other than that, and also the new homework will be assigned next few days. I didn't make it yet. Meantime, we'll take uh, 1 week relax to think about database access control and authorization. And then next we will do Python, okay, SQL embedded Python. Oh, next week, by the way, no class, but a week from that. All right. so, so you have time. So today, the access control, some of those we already had uh, hands-on exercise. Some, this is more uh, uh, the whole picture of access control in databases. So what is access control? So access control ensures that all direct access to object are authorized. That is access control. So access control protects against accidental and malicious threats by regulating the read-write execution of data and programs. Simply, we can say by regulating the database actions. Typically, in databases, uh, we consider 3 types of actions: read, write, and execution. That is typical way that we consider also operating systems. Some of you may or may not uh, knowing about the Linux operating systems and uh, command line executions. In Linux operating systems, there are also 3 actions have been considered when they are talking about access control: read, write, and executions. Anybody do not yet know about Linux? Raise your hand. You guys all know Linux. Kripesh, you know the Linux operating systems commands.
I have used Red Hat command.
Oh, great. Then you may know that. We may or may not, in this class, to when it comes to um, the graphical user interface of database access, then we may, I'm thinking of, but it depends on, may or may not, we set up uh, 2 or more Linux guest operating systems on the VirtualBox, particularly VirtualBox of the Oracle. and then we can set up 2 or more Linux guest virtual machine, and we run on one virtual machine's MySQL, and may set up a web server in one, or we can simply access from other the virtual machines. So it would be a little bit of a distributed fashion of database management. So we may do that, but it requires some of the skill sets. So I am not sure you guys have the skill sets of set up VirtualBox and set up multiple the Linux virtual machines, and then let them talk each other within VirtualBox. Not just using VAT, but I think it is called the VAT network. Have you guys set up a VAT network on VirtualBox, so that if you have 2 or more Linux operating systems running on your VirtualBox, then from one operating system you can connect it to another operating system. That is very, very, very similar to the real world, the distributed systems. So we may try to do that. But anyway, so if you guys know a little bit of Linux operating systems and the others, I can let you know how you can set up. But Linux operating systems, I cannot teach you in this short time period. Other setting up and configurations, anyway, we could do that. You can build your MySQL on one of the box, and you can access from other systems. But anyway, by doing that, database access control is very similar to Linux operating systems access control. Particularly the actions, the atomic unit of actions that we consider on database are exactly the same, those atomic actions in Linux operating systems, which is read, write, and executions. So access control requires proper user identifications and information specifying the access right is protected from modifications. This is based upon that user identification, we can set up user access. That's what we did for MySQL on MySQL once, right? You can create users with the some of the identifications. Identification is nothing but in MySQL the password, right? Add and create a user identified by password, and you can get in the database by using that password. That's what we did. Information, okay. So actually, 2 things that should be ready. Access control policy. So to what person you are going to allow on what the action, on what object. That's what we had on MySQL, right? So you can grant some actions, grant select, or grant all privileges, then grant all, grant select, grant delete, grant create, followed by on an object. If you say on star dot star, then there's any database, any table. If you say payroll database is only user table, then you need to say payroll dot user. That is a target object. And then you can give to some user. That is an access control policy. Access control mechanism, there's a real implementation. Mechanisms usually provided. Unless you are building your own database management system, then you simply use MySQL. The MySQL has already some mechanism. You don't really set up the mechanism itself. You simply use something in the way it is allowed. It is implemented. Okay? So, how to specify access control? So basically, access control needs to be specified over subject, object, and access rights, privileges. Subject, who? The user. Object, target. Are you going to define your access control policies on record by record or table by table, which is a relation, or file by file? File could be an entire database, but not necessarily. One file, one physical file may contain multiple databases, or a database may need more than one file to store. If a database is gigantic, big, then it's not a good idea to put all the database in one physical file. If somebody take that file, then you lose everything, right? So ideally, even if it's not really gigantic, big, the size of a database, ideally you can distribute some tables on some files. So even if one file is compromised, you don't really entire database not necessarily damaged. And then you have to consider, you have to think of some of the privileges. What kind of privileges that you are going to grant or revoke. If you are considering database, then read, write, and execute. If you are considering Linux operating systems, same thing. But in the database community, the researchers try to make little finer granules of privileges. Not just execute, but what type of work that are you going to do? For example, write, then are you considering also copy? Copy will be a is a write privileges or a read privileges? Copy is a little bit trickier, right? Electronically. Many things needs to be considered, but basically read, write, and executions. Protect object to be protected could be entire database or a table, which is a relation in relational database. Record, which is a row. Attribute, within a row there is an attribute. some of the elements, even smaller than that. If attribute is a composite type, like address, then entire is an address. 555 Broadway, Dobbs Ferry, New York 10522. That is Dobbs Ferry campus address. What is an element? Maybe city, Dobbs Ferry. So out of address attributes, we can protect. We want to protect the city name, or we want to protect the street number. 555. Different granules may be considered. These are all the terminologies used in databases. But sometimes we can combine this with the operating system's terminologies, like file. File is an object used in operating system. Then one file could be one database. As I said earlier, one file could be multiple databases. One file could be partial database. We can think of a relation level of granularity, which is a entire table. Particularly in this case, there is a salary table. Salary table is it's a sensitive, right? So entire table maybe you can grant the read privileges to read privileges on this particular confidential table to Lolu, right? If she is working at the payroll department. Because we trusted her, she doesn't touch salary attribute. If you need to do, you can touch mine. Only increment way, not decrement way. Or tuple level, record level. For example, Smith and Black records are sensitive, but not the records about Dell. That may be possible, right? If we are thinking of a Mercy University payroll table, then the pay for the president should not be secret, because nothing can compare with her pay, right? But it is really sensitive if I know my colleague's pay, and if he or she knows mine, then someone may be encouraged, someone may be deeply discouraged. That may agitate anger or some of the unsatisfactions and all kind of issues available. So record by record. Attribute level as well. Why do we need to authorize entire table per user? User may be able to see who is working for what organizations, but only the salary number itself. Then we can we need to consider that is sensitive. Therefore, we apply the access control policies. So who can access what kind of salaries? Of course, each record owner can access his or her salary. And also, what about supervisor? Supervisor can access not only his or her salary itself, but also anyone working for that supervisor. It's very natural that way the supervisor may uh, decide next year salaries, right? If the salary is determined by the supervisor. If salary is determined by someone else, then that person may access uh, that salary information. Unless otherwise, then that person cannot do some reward or anything, I mean, no manipulations, no updates possible. So all such things are the policies. So we need to first define a policy, and then we need to implement that policy electronically on our DBMS. Usually DBMS does not provide that mechanisms because there is application details, application dependent policies. So mechanism is not really provided. Then what should we do? Therefore, the coding is needed. In our case, the Python can do some of implementation to handle that. For example, if that person is not only the user, but also manager, then manager needs to see the salary information of all the subordinates. Anybody who are working for that manager, the salary needs to be accessed by the manager. So each individual team members cannot see among themselves, but manager needs to be accessible. Cell levels, each cell differently. It's not necessarily attributes. It's not necessarily tuple. Tuple is, by the way, is nothing but a record. Record is more likely that is a logical term or operating system terminologies. Tuple is more database terminologies. So tuple level granularities that we looked at, which is the same as the record levels, or attribute levels that we looked at on the previous slide. On this slide, we're talking about cell levels. Each cell may have that differently. It's like ad hoc policies. There's no rigid standard rules to apply. But for example, tell the name of person, oh, that is a sensitive. If that person, whatever the reason, maybe company name, maybe sensitive to our table. Salaries. So we simply point. This is P for public. This is public, public, public. C for confidential. Confidential, 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 confidential. This guy needs to be confidential also, right? Bells. Or public. In this case, public. Because it's white. Right? So Access control management. So we have a subject, access policy, and objects. We can authorize the user itself, or we can authorize not only user but depending upon user's role. Remember that when we create a user in MySQL, as far as that user comes in MySQL, always the same privileges is granted to that user. In other words, a user does not access the database differently. At this time, oh, I want to access a regular user. At another time, I want to access like I am the manager. At another time, I want to access as auditor, things like that. MySQL does not support that, right? But some other database, for example, Oracle, then remember that we access, when we open up my database, we say MySQL minus U followed by username and minus P. There's a no minus R for role. In my case, for example, MySQL minus U Jae-yoon minus R as a faculty and minus P. And then I can enter my password. That session is only applicable to John Yoon as the faculty role. So role-based access control has been developed and considered in database communities for about decades. When the role-based access control was first tossed out, it was really, really brand new ideas. Everyone's delighted, and it was really immediately implemented in the Oracle databases. It has been about I think 20 years already. So role-based access control is not new, but still operating systems does not provide that mechanism, role-based. If one user, then always the same role. Whatever the role that person is, that person can do. But in operating systems, there is something else, user group. Remember that in Linux operating systems, so when you create user in Linux operating systems, you always ask you to enter user ID and the group that user needs to be involved in. That is something good in Linux operating systems, right? So user group, each students can be in the user group students, or each faculty members can be in the user group faculty, and so on and so forth. So authentication management we have access server. To that access server, maybe policy needs to be stored somewhere, so that policy in the policy repositories, one policy may be selected and apply for that access controls. Okay, so policy manager is the user interface for creating and managing authentication policy for the application services. That is policy manager. Access server accept requests from the enforcement points for access control decisions and returns the result of that access procedures. An access gate that is embedded in the application. Therefore, if you set up web applications through that applications to access internal databases, then here on this web application can contain access gate. So you can, in order to access a database, which is behind this, somewhere here, if you set up web applications, then outside here, user can access that web application where there is an access gate. So through this access gate to access the back-end databases. That is very, very typical, right? These days. Authorization management. So we have a policy repositories holding all the authorization policies. So where is policy? Yeah, here, policy repositories. And policy information point. Here, policy information points. That is a provider of a policy data to the decisions and the enforcement points. Up here, there is an application. And policy administrations, here, sitting at the low level. There's a user interface where administrator can define policies. So this admin can define this policy so that updates these policy repositories, and also policy decision points needs to be handled by these policy administrators. This policy decision point, that is an engine that can decide whether to grant or deny access to user based on the information it is provided. Once it is done throughout all, then actually we can say these guys can do some of the policy enforcement. So policy can be enforced. So this is one policy is picked here, and then decide whether it is granted or denied. Once it is done, then that is enforced. Access control policies, three or more types, three or more mechanisms available. First, discretionary and mandatory and role-based access control. The mandatory is more common. Like Linux operating systems, access control mechanism is based upon mandatory access control. What it does is that user and objects, target objects, are already defined. This object is top secret. That object is just a secret. The other object may be confidential. The other one may be unclassified. So multiple different levels of sensitiveness already defined. So object, documents, data items are classified that way. If it is classified, then it's a top secret or secret, confidential, unclassified. That is very, very convenient and has been used in military from the beginning, many, many decades, for many, many decades. And also user has different levels. You have top secret clearance. Someone has only secret clearance. Someone has confidential clearance. Someone has just casual users. Depending upon, let's say, if I have a top secret clearance, then I am authorized to access a top secret object. So we have subject and object already declared. This one is top secret user. This one is a top secret document. Yeah, then you can access this. This guy has casual user. I have top secret documents. No, no, no. You cannot access. That is mandatory. That is easy to implement, right? That has been implemented in Linux operating systems from the beginning. Very simple. But database management systems, mandatory access control is not enough. It's not sufficient. So we developed further discretionary or even further role-based. So next slide is describing about discretionary access controls. So for each subject, access right to the objects are defined. So actually, three components: subject, object, and action. Subject, object, and action. Basically, three components. So subject objects are not predefined. Subject objects are not pre-classified, and that classification goes permanently. That's not, right? That is a mandatory. Here in discretionaries, all relatives. I have an object, depending upon who wants to see, decision will be different. So user-based, object-based. So it could be that privileges could be granted at one time, but at another time it can be revoked. So dynamic. Propagation of access right. Maybe the problem when there is a delegations. I'm the subject, so I am authorized to access some of the object. I can copy it. I am authorized to copy that document. But usually I don't do that. I want to ask my secretary to do that. What happens in that case? That is a propagation, right? Usually that happens in the real world. Should we allow it? Is it legal delegations? In the real world, there's a legal delegations can do, right? Then could we do in database as well? That type of problems is still unsolved, right? Reasonably likely possible, but what kind of mechanisms and how that mechanism can be implemented in my database. That is the issue. Revocation of propagated access rights. For example, so I am the CEO of my company, therefore government allow me to access some of the governmental documents. So I ask my secretary to get the copy from that. And my secretary didn't do it. So she wants to go there next week. But in the meantime, my authorizations is provoked. But I already gave my privileges to my secretary. If my authorization is provoked, then what about my delegations? She holds the privileges right now that I gave to her. Is it automatically provoked, or some other way that we can consider? It's not really formally articulated. It should be somehow treated, right? That's what we are saying. Problem. So this is the thing. Grant select on employees to black with the grant options. With the grant option means the black now can select any records from employee table, right? With the grant option means black can also authorize, black can grant select privileges on employee to someone else as well. That is the delegations. The read here, red now is granted to select on employees, right? But there is no grant options. Brown, since Brown has the grant options, black, not Brown. Whoops. This is something not really correct. Oh, wait a minute. Okay. I didn't look at the arrows properly. Okay. So Brown is the owner. So grant the privilege to black. This is black. But black has the grant options. So that black further grant to red. That is the scenario, right? So red has it's a kind of delegations, right? Red has, let's see, this is me, CEO. This is my secretary. And owner, I'm also update privileges on salary to white here. Brown revoke grant given to black. Of course, Brown can do revoke, but then what happens? This red privileges. Currently, red has the privileges, right? That type of things. It should be cascaded. The revocations. Implementations. Access control list. So we have columns. Let's say file 1 contains Joe can read, Joe can write. File 1 can Joe can read, write, and owner is Joe. So owner can do everything. Joe can read, Sam can read, Joe can write, and Sam is the owner. Capability list row. Joe so file 1, file 2, this is an object. It could be a real file or could be a database data, data items, maybe records, maybe table, maybe entire database, different granules. Capability list. So based upon this, we can think of Joe can read file 1. So this is subject, object, and action. Subject, object, action. Subject Joe can write on file 1. Joe owns file 1. Joe reads file 2. Like Sam reads file 2. That can come from this Sam. Sam write file 2. Sam owns file 2. Okay, this is an access control triples can be determined. Therefore, Joe can read file 1, Joe can write file 1. This is generated from this very easily. So this kind of access control policies will be very likely applied to here. This is a policy repository so that we can apply. Decision is more automatic once we have this kind of triples. Access control mechanisms, security through stored object, so security through views, stored procedures, grant and revoke, query modifications. That mechanisms, if we go through the views, then let's say we create views. Outstanding object as a select name, course, grade from students, where grade B's. So then we can see the outstanding students view, which is not base table but view. But this is another story. Difficult to maintain objects updates. That is the view. If we want to update something on this view, it is prohibited because this is not base table. You can update anything on the base table, but not the views. Views, only view. What that means is that we simply read it. Store the procedures. We can assign rights to execute, to compile the programs. So grant to run on the program to particular user. So this is some of the privileges, right? Run on the procedures, some of the programs. Not all the people can run the procedures that we prepared, but only a particular person can run these procedures. That is possible. This kind of we can manipulate this encoding very easily. Right? So we will do this a little bit of those procedures. Grant and revoke. The language is grant privileges on relation to user with options. So example of select privileges. If we have a star dot star, then as I said, the star, first star will be the database, followed by dot, and then second star will be the table. So a particular table on particular database, that is an object. And we have particular privileges, particular, oh, wait a minute. on, this is a table. What is this? Select star. Or this is any kind of select. Okay. On this student table. This is a table. Grant select. We can select any attributes. Update. Only the grade update on students to Frank Farkas. Grant select. Select name only, not any kind of attribute names, but name only. From student table to Brown. So grant command applied to base relations as well as views. So this student here, it could be a base table or a view possible. This language is not really standardized. If a star does not work, then you drop this. I'm not sure on MySQL. You can try whether it works or not. But definitely it works. Select on database.table, but not the specific attributes. I'm not sure. Then that is more granularity, right? Attribute based granularity is implemented in a DBMS. It could be MySQL, it could be Oracle. Question? Comments so far? So far, so good? So we do not hands-on today. Because some of hands-on we already did. We don't really. The theory that we looked at today's slides, not all of them are available in MySQL. But I think most of this are available on Oracle, particularly role-based access control is not available on MySQL. Revoke. We need to revoke privileges on the relation from particular user. So once we grant the privileges to the name blue, username blue, then we can revoke one or more privileges from the user. That privilege is applicable to on objects, the table name here. Oh, this is it. But I think one more thing that we didn't do here, role-based access control. I think we should say this, role-based access control. When we grant the user and then as role, this, not only this, but for example here, so privileges on relation to user as role. So when user tries to access a database, then our decision is made based upon the role that user wants to access. But that role-based access control is only available when DBMS allow user to access as a specific role. MySQL does not require, right? Only username and password. So role, if it is required, then we can use that, role-based. That is more realistic. Each person, when that person comes in my database, that person might have different actions, different views to access. View from manager's privileges, or view from CEO's privileges, or view from faculty, view from students. So all kinds of different roles may be applied. That's role-based. I think this is all I prepared for today. Too short for today. And I am going to give you the homework assignments of SQL DML. We rested 1 week. Don't do any SQL assignments, right? So we'll do that. So I'm going to make some interesting SQL DML for your exercise. I realized that if I don't give you homework assignments, then my recordings, my lecture, so viewer is very, very low. So no one wants to come back and watch. But when I give assignments, then reasonable number of students come and view. So I realized that, so students do not study if I don't give homework assignments. I realized that. That's my statistics.
So, right here you have in this side you have non-cascading revoke and cascading revoke. What is that?
Cascading and non-cascading is up to, that's a policy that you have to decide. Yeah. It's not determined, right? Like in reference foreign constraints, like student's ID, student CWID is a primary key. But that CWID appears in the enrollment table. Then CWID in enrollment table, that is a foreign key. What if CWID is removed from student table? Then we have to decide our policies, right? We want to make a cascade. Then deletion should be, effective deletion should be cascaded. So a student is removed from student table, then whatever, because of that, whatever other records whatever other table has that value as a foreign key, that should be automatically deleted. That is, if that is a real world case, then we have to do that, right? In the case of student and registration, yes, it should be cascaded, right? But not all the time. Some other cases, not really, right? For example, you are customer to you are a customer to Amazon. So you have Amazon has your customer information in customer tables, and there is a purchase table. There's a transaction tables. So although you are removed from that customer table, you said, "Oh, I do not want to pay my memberships." What membership is it called? Amazon's, huh? Yeah, Prime membership. I want to stop my Prime memberships. So your name is from that customers tables. Still, you want to buy, right? Purchase, but originally you are the customers. Then that customer's number appearing on that purchase table, there is a foreign key, right? So if somebody wants to see, oh, let me see more detailed information about this buyer's information, then we can go back to the customer's table, right? Even if that is removed, that that's not cascaded to be deleted. Still stay there. Therefore, we cannot access the detailed customer information, but still that purchase item is valid. Then it should not be cascaded. But school student and registration, that is cascaded. It depends, right? Similarly, here, grant and provoke, it depends on the scenarios. Therefore, access control policy is important. It's not really one rule to be applied. If it's not one rule to be applied, then we have to describe the policies, like this kind of policies, right? We can remove this. Then at that point, Joe cannot read, right? So each of these the records may be valid, but not all the times. Any other question? Kripesh, question.
Suppose you're a T-Mobile user, so you've added one line under yourself, and then you've decided to remove T-Mobile subscriptions. So if you remove your subscriptions, the person you've added under yourself will be automatically removed, or
That is also their policies, right?
yeah.
Then they may ask you, oh, you wanna stop everyone's subscriptions, or you only yourself, right? So there is a scenarios. Scenario may be created in that case. So cascading, or the impact from one the privileges change impact from the privilege changes. It's not only always uniformly enforced. Some applications maybe. Some applications definitely, if you are removed completely, our policy is cascading. Remove everything. No other options. Then you have to do, right? So that is their policy. It's not system issue. Their business issue, business policy definition issues. Sounds good? Okay. So next week, no class. Why? I already explained. You can come back to see the recordings. Faculty seminar days. So daytime, no class.
So you guys sit down and you just talk to me?
Seminar days? Some seminar days I give my talk, but not this time. Simply listen.
So all of the faculty will be on the seminar, or
Yeah.
Evening class is still
Evening class is still valid. So if you have evening class, it doesn't affect to that evening class. Next week, once a semester. All right. So see you in 2 weeks.